Hello everyone, myself Mayank Sharma, and today I am going to present you on the topic Agricultural Decision Support System (ADSS) Software Architectures in Smart Agricultural Platforms. In this presentation, we will understand how modern smart agriculture platforms integrate IoT sensors, weather data, predictive analytics, and more importantly, how different software architectures make this integration efficient, scalable, and reliable. So let us start with the introduction to ADSS only. So ADSS are intelligent systems designed to help farmers make better decisions using data. These systems collect real-time information from IoT sensors placed in the field. They integrate weather forecasts from external APIs. They use predictive analytics to estimate crop yield, disease risk, and irrigation requirements. All of this data is processed to provide actionable insights to farmers. But for this entire ecosystem to function smoothly, we need a thing called as software architecture. So architecture defines how all of these components communicate, scale, and remain secure. So next, we will go on to understand why there is a need for architecture in smart agriculture. Smart agriculture platforms deal with continuous stream of sensor data. Weather APIs constantly provide new updates. Predictive models require significant computing power. If there is no proper architecture, data may not flow correctly. Real-time decisions may be delayed. The system may fail under heavy load. That is why architecture ensures modularity, scalability, reliability, and security. So now let us explore the three architectures discussed in the research paper referenced in this presentation. So first architecture that we are going to understand is layered architecture. In the research diagram that you can see, the system is structured into four main layers. At the bottom, we have the perception layer. This layer includes all the IoT devices and sensor deployed in the field. These devices collect soil moisture, humidity, temperature, and other environmental data. Above that or besides that, are network layers. These layers are responsible for transmitting the collected data. It uses wireless technologies like Wi-Fi, LoRa, or cellular networks. It ensures that the data moves securely from the field to the processing environment. Next comes the middleware layer. This is where data is aggregated, processed, and stored. This layer also integrates weather APIs, manages authentication, and security mechanism. Finally, at the top, we have the application layer. This is where dashboards, predictive analytic results, and recommendations are displayed to farmers. So the data flow is basically like first is perception, second is network, third is middleware, and fourth is application. So moving on to the usage of layered architecture, as per the research paper that we have referenced over here in this presentation. So it is used for structured smart farming environments. It emphasizes security and privacy by clearing separating layers. It works well for medium scale farms where infrastructure is stable. However, it may not scale efficiently for very large enterprise systems. Moving on to the next architecture, that is edge cloud hybrid architecture. In this model, the system is divided into four parts. Again, at the base, we have the device layer. This includes IoT sensors and agricultural devices deployed in the field. Instead of sending all data directly to the cloud, the data first goes to the edge layer. The edge layer is located close to the farm. It performs local processing. For example, if soil moisture drops below a threshold, the edge system can immediately activate irrigation. This reduces latency and does not depend entirely on internet connections. Then we have the cloud layer. The cloud performs heavy operations such as long-term storage, big data analysis, AI-based crop prediction, weather data integration. Finally, the application layer displays results to the farmers through dashboards and mobile apps. Next, we'll understand the usage for this architecture. This architecture is ideal for remote agricultural regions. It allows real-time irrigation control at the edge level. The cloud handles complex predictive analytics. It reduces bandwidth consumption and improves reliability. This makes it highly suitable for large geographical distributed farms. Next, we'll go to our final architecture, that is microservices-based architecture. Unlike layered architecture, this model divides the system into independent services. In the first diagram, we see that the client layer where farmers access the system via mobile or web applications. Requests go through an API gateway which acts as a central routing component. Behind the gateway, there are independent microservices such as IoT data service, weather service, analytics service, notification service. Each service performs a specific function, operates independently. In the second diagram, we see how these services are deployed. In each microservice may run inside its own container. Each service may also maintain its own database. Services communicate through REST APIs or message brokers. This ensures loose coupling and independent scalability. Now let us discuss their usage. So basically this architecture is designed for large-scale agricultural platforms. It supports integration of heterogeneous data stores or sources. It enables distributed predictive analytics. It is ideal for enterprise level agri-tech companies handling massive datasets. However, it introduces higher system complexity. So now let us summarize based on a table that we are having here in this presentation. So layered architecture is best for medium farms with stable infrastructure. Edge cloud architecture is ideal for remote farms where real-time responses is critical. Microservices architecture is suitable for large enterprises, agri-tech platforms requiring scalability. So the choice of architecture depends upon the farm size, the connectivity conditions, the budget, or the scalability requirements. Next, we'll discuss about the conclusion. Let's summarize till now what all things that we have understood till now. So first of all, the smart irrigation, smart agriculture platforms rely heavily on strong agricultural or architectural designs. IoT, weather integration, and predictive analytics must be coordinated respectively or effectively. Layered architecture offers structured and simplicity. Edge cloud architecture provides real-time responsiveness and reliability. Microservices architecture ensures high scalability and flexibility. Selecting the right architecture enhances productivity, sustainability, and long-term efficiency. So these are the references that I have put or also have referenced in from this paper presentations that are published. So you can go through these links and go to the papers which I have referenced in this presentation. So thanks for watching this video. I hope this presentation helped you understand how software architectures power modern smart agricultural platforms. If you find this information informative, please like, share and subscribe. Thank you for watching this video again.